Okay, this is video number 3. Before I get started in any more repairs, I just want to give you a brief overview of maybe the labor force, the economic conditions, and some of the manufacturing methods of the day when this guitar was manufactured. Now you got to remember, this was probably 25 or 30 years after the Civil War. So quality material and quality labor was probably allocated to things other than leisure products. In fact, according to the U.S. labor statistics, there were only about 2 million people in the labor force at that time, 18% of which was considered child labor. Now, that may have been because of a loss of life during the Civil War, or it could have been because families who moved to the city didn't need the kids to work on the farm anymore because they had moved to the city. But at any rate, about 18% of the labor force was considered child labor, which meant that they were between 10 and 15 years old. Electrification in the factories didn't happen until well up into the 30s. So all machinery, virtually all machinery, was steam driven, which made for some pretty sweltering conditions in the factories, I'm sure. Summertime heat in those places is probably where the term sweatshop came from. Factories were sometimes 2- and 3-story buildings, and obviously had no lighting because kerosene lighting was kind of dangerous in a woodworking shop with all the dust and wood chips and things floating around. So that was pretty risky. So, and that's probably one of the contributing factors to working 10-hour days, because it was difficult to light during the nighttime to see, for the workers to see what they're doing. And that's another reason you see a lot of windows in these older manufacturing buildings, lines and lines of windows. Gluing, the methods for gluing were, I'm sure the methods for manufacturing in the luthier trade is almost exclusively gluing. There's no metal or metallic or mechanical fasteners of any kind in the luthier trade. It's all put together with glue. And the fact that there were some unskilled workers in the workforce probably meant that there was minimal prep and cleanup and quality control and those sorts of things. And I'm seeing a lot of that. There's a lot of glue residue all over not only the inside, but on the outside under the finishes as well. In fact, we've talked briefly in the past about, on a previous video, about glue squeeze out is our enemy. So we always try to limit that because it affects finishes and so on and so forth. Also, we looked at some machining mistakes last time, and they were kind of covered up or accommodated and not redone probably because they were prevalent and they couldn't afford to keep redoing things. All of these conditions led to a reduced life of the end product. Now, this particular guitar has survived probably because it wasn't played in 90 years, and it spent 30 or 40 years in Dad's attic, and although it was extremely hot, and that probably contributed to it, falling into pieces, but essentially it was all there. It's intact. There's some interesting thing that I want to show you with regard to the sweatshop thing. Anyone who has a workshop, does woodworking, will tell you that, especially if they live in an unconditioned workshop, that sweat stains are a disaster for unfinished wood. If you're finishing a fine wood surface, a sweat stain can ruin it because it's virtually impossible to eliminate. Well, I want to show you an example of that So I'm going to pause this video and we're going to take a look at some of the manufacturing conditions that'll bring you a little closer, maybe give you an idea what it was like to stand up against the bench in a woodworking shop in the late 1800s. Okay, I'm sorry for the blips and glitches in that, but I want to show you something. This is the back of the guitar. And the blue arrows are highlighting a sweat stain. I know that's a sweat stain because I've produced them myself. And if you look closely, you can maybe zoom in on that. You can plainly see it's not an error or a grain. I'm sorry, it's not an anomaly in the wood grain. The wood grain is perfectly uniform there. But if you look carefully at that, you can imagine a sweat stain that was swiped off with maybe a dry rag or something. There's another one right here. I don't know if you can see him. Also a sweat stain. Was wiped off, dripped on and then wiped off. I hope these are focused. And here's another. This is a very predominant one. It's very pronounced. You can see it quite well. It's a sweat stain that was dropped onto the finished wood before it was finished and then swiped off with a dry rag. And here's still another. You can see that very plainly. It's a drop. That's a spot in the wood that was not there when the wood was new. That spot was under the finish and it was not cleaned off because they couldn't clean it off. Okay, interesting stuff, those sweat stains. Very typical, and it gives you an insight into the working conditions in that factory by someone humped over a workbench, sweltering in the heat. Hopefully he had a window beside him. Anyway, today is we're gonna talk about the bridge repair. I'm gonna let you zoom in on this a little bit, and you can see these holes in the face of the guitar. This is called the soundboard side, and if you look closely, you can see they're quite elongated, and they're elongated because of the age and the stress that would put the strings put on the face of the guitar. This was the hand-carved bridge that was on the guitar when I received it. It was put over the holes to replace the original, which actually looked like this. It would have been placed over the holes. I can tell that the original was like this because it has 6 holes here that the strings actually went through and were attached. Now originally, the guitar string, you see it has a little sort of a brass bead on the end of it. That bead would have passed through the bridge and gone into this hole. If you see the holes, you can see that that because of all the stress that was put on the string, it eventually pulled out of the head of the guitar and the face of the guitar. And that rendered the guitar virtually unplayable because the strings were no longer held in place. Their attempt to repair that was with what we call a floating bridge. It was actually put on a couple of rollers like this right here. And it was put over the holes. And since the holes were no longer acceptable, would no longer work to hold the string, they put what's called a saddle. This is what's called a metal saddle, and allowed it to hold on to the string, was mounted to the back of the guitar, put over the bridge, and then attached to the head. But the stress that this produced on the head, on the soundboard of the guitar, is what caused it to bow and eventually fall in disrepair and unable to use it. So what do we have to do to get the bridge put back in shape so that these holes will not be destroyed with the weight of the strings? Well, we have to plug those holes. Now, we do that by putting a small plug in each hole. Now, as maybe you can tell, I've drilled those out. But because of the size of the holes, a small drill will not drill all of the damage away. So what we're going to do is we're going to put a small plug in each one, and then after the glue sets up, we're going to put in drill another hole. I'm going to put in a plug and show you what this looks like. Put in a couple of them. The plugs are put in place. Now I'll glue those in place and smooth them off. But as you can see, they do not cover the entire hole. So once the glue sets, I will drill another hole offset from the first and put in another plug. So it'll be like a little figure-8 shaped plug in there. It's the only way that we can hide that damage or repair that damage. Now, all of this will be underneath of the new bridge, which is also glued on, which will definitely add strength. But in an effort to make a clean hole for the string to pass through, we've got to repair the old hole. Even though it's underneath, we still have to repair the hole. Now, how do we keep that from happening again? After all, this is a soft top. This is soft wood. This is hardwood, but it's the soft wood that's holding on to the bead. When we put the string in the hole, it's held in place by a tapered pin. I don't know if you can see this, but I'm going to try to show you. Do you see the groove in the pin? There's a groove in the face of that pin. And what happens is when you shove the pin in the hole, the string tries to pull up through the hole, but it's stopped by the brass pin, by the brass end on the pin. And that keeps it from pulling up through the deck. But it doesn't prevent it from bearing against the soft wood. So what we're going to do is on the inside, we're going to put in what's called a bridge plate. The purpose of the bridge plate is to cover up the holes on the inside. Now this is a hardwood bridge plate. It's made out of walnut. And if you look, you'll see that the grain is slightly skewed from straight. The reason for that is that when we re-drill the holes in a straight line, they do not fall down a grain line and weaken this plate. So that the holes, although they're in a straight row, are not in the same vein of grain as they progress across the face of the guitar. Now to make the plugs, we use what's called a plug cutter. This is a plug cutter. And I've got a whole bunch of them right here. A lot of plug cutters, lots of different sizes. This particular one cuts a 1/4 inch plug. Now the inside of this bit is tapered so that when you drill a plug out, the top of the plug is slightly smaller in diameter than the bottom. And when you drill a hole with a plug cutter, that's what it looks like. And we just take a small screwdriver or something, we push sideways on that and pry it out, and that's our plug. Now this is the same wood, same species of wood as the soundboard, so that hopefully we'll be able to try to match some grain. Even though we'll never see it again, we'll try to line up that grain just for practice. Okay, so we're going to attempt to glue in a couple plugs here, and I'll finish off screen, but I want to give you an idea how this works. First thing we're going to do, And I've numbered these plugs because they match. I tried to match the grain pattern in the face of the wood. So the first thing we have to do, of course, is put a little glue on there. So here's our glue. We're going to glue the plug. And then, of course, we're going to glue the hole. This is hole number 3, so we're going to glue hole number 3 first. So I'm going to reach in underneath. I'm going to force the plug into the hole best I can. Wipe off that excess glue so we can see the grain pattern and see if we can turn the grain to somehow match, or make some attempt to match the grain pattern in the face of the guitar. Each plug has its own grain pattern, of course. So we're going to take another plug. We're going to do the same. We're going to glue the plug. We're going to glue the hole. We're going to reach underneath, try to push that plug, making some attempt to line up the grain patterns. Now I'm pushing them through a little bit farther than flush so that we can trim them off neatly before we drill the second hole. I'm going to take another plug, glue the number 1 hole. Trying again to look at the grain pattern and get it to match what's in the guitar. Push it through a little extra so that we can trim it off later. I'm going to turn that over. Remember, glue squeeze out is our enemy. So we want to make sure we get rid of all the excess glue, because after all, our bridge backing plate has to be glued down and it has to be very flush in here. So any glue squeeze out that remains, we're going to have to manually chip away at and cut off of there. All of this will eventually be covered up with the new bridge, but the surface of the soundboard will be intact so that we can drill new holes through the bridge backing plate so that the string itself can be held firmly against the hardened wood. I'll finish the rest of these plugs off camera, and then the next video I'll have the secondary holes drilled, and we'll put in 6 more plugs and see if we can solidify this top a little bit. Okay, so there we've done it. We've filled the first holes. Now we'll drill where we have to, we'll drill a secondary hole and we'll put another plug in that secondary hole that will cover up the excess. Now the holes may overlap. That's why we had to put one set of plugs in. We may partially drill away the first plug in order to get the second plug to fit snugly. And when we get all those holes, when I get this smoothed off, planed off smooth, and the holes, secondary holes re-drilled, we'll put that in a video and show you how we sealed those holes up.